Hello, welcome back. In the last video in March, we were testing this 400 amp Amatec bistable contactor to reduce parasitic loads on a solar storage battery. I was waiting for this DuraKool brand. This is a 300 amp bistable latching contactor. Just for comparison, it's a little bit more compact, a little bit lighter weight, but it's still good for 300 amps, which should cover most use cases. And it costs a little bit less. This is a $65 bistable contactor. It's made in China. It's from American Electronic Components in Elkhart, Indiana. This is their brand. With the tariffs and with shipping, it's about $125. It's available with 3 different style of mounting brackets. It's an L bracket, P bracket, mounting like so, and this is a standard W bracket. This seems to be what comes standard on most devices off the shelf, unless you specify something different. When I ordered this product, there's actually 2 different models. This is their DSC30M, and they do have a DSC30. It has bus bars with 2 holes in it, which I thought was a nice feature in case you wanted to gang a couple batteries together in one spot and not have to purchase a separate bus bar. This is shown with auxiliary contacts, which I did not order. It has a lower voltage rating because it doesn't have magnetic arc blowout. This is rated up to 120 volts DC, one with the studs, 8mm studs. This one does not, so it's only rated at 60 volts DC, but it's still a 300 amp contactor. And unfortunately I ended up getting 2 of these instead of 1 of these and 1 of those. But the price is the same and the internal components are the same. So for testing purposes it really doesn't matter. This one apparently comes with an L bracket or a P bracket or an I bracket, which I'm not exactly sure what that is because their literature doesn't describe it and it's not shown in the drawings. This is the test setup. This is a DIY BMS system that I'm working on. We're going to basically be doing the same thing. I'm just going to use cold water to simulate a low temperature condition, which should open the onboard mechanical relay and in turn should open this relay and cycle this to the off position. Let's give it a try. I think I have the temperature set at 40 degrees, so once it goes below 40 with this ice water, it should shut off. And if you notice, there's a little delay. This pilot light is hooked up to the onboard relay, and this pilot light is hooked up to the contacts. Now the temperature is going back up, and it cycled back on. Again. BMS seems like it's got a little bit of a delay in reacting. Like I said, it's a work in progress. This is the standby load. It's 5 milliamps. Let's cycle it, see if we can capture the inrush. So that's not bad. 4 to 5 milliamp standby load as compared to 340 for a 400 amp standard contactor and about 115 milliamps for that 200 amp contactor that I'm using now. And as I was mentioning last time, this is my zero delay board. I added a couple of components. And I had a 3D printed base plate made for this version 3.1, and the capacitor has been reduced to 56 microfarads, so it's a little bit faster to react. So I think what we're going to do next, as promised, this is my zero delay board. I'm going to swap them out and just make sure it works as advertised. So when the pilot light here goes out, this should go out immediately with no delay. Let's see if that works. And with version 4.0, let's double check it. Yeah, it's interesting. This BMS reacts faster as the temperature is going down. Ruh-roh. Alright, well there you go. That's an epic fail right there. It's alright, I never intended to use the zero delay board in any case. I'm going to go ahead and put this and this, my 120 amp hour battery, and get rid of that crappy always energized golf cart style contactor. Cut my parasitic load down.